welcome to the Deep Dive. Today we are diving into the world of building codes, which, let's be honest, can feel like a place shrouded in acronyms and just a lot of bureaucratic fog.
It really can.
But if you're planning a renovation, building a new home, or designing any kind of structure, this is a conversation you absolutely need to hear. Our mission today is to cut through the confusion around two of the most critical code documents in the U.S.
The IRC and the IBC.
Exactly. And almost everyone gets them wrong.
They do. These two little acronyms are responsible for more budget overruns and, timeline delays than almost anything else in construction planning. You're so right to highlight the common mistake. People just instantly label them the residential code and the commercial code.
And that seemingly innocent simplification is a financial.
It's a landmine, a total landmine. The stakes are genuinely high. Mistaking your project's code identity can mean designing an entire structure only to have permitting just reject it.
And you're forced back to square one.
Precisely. That realization that you designed for the completely wrong set of rules can cost you tens of thousands of dollars and months of time. So if you're starting a build, understanding the difference between the International Residential Code, the IRC, and the International Building Code, the IBC, it's crucial.
Okay, let's unpack this then. We have to start with the fundamental question. Why do we even have two different code systems that seem to overlap? Why didn't the International Code Council, or the ICC, just write one giant rule book for everything?
That's the perfect place to start. It's really the key to the entire discussion. Both codes, they come from the International Code Council, the ICC. They draft these model codes, and then states and cities adopt them, sometimes with a few changes.
Okay.
And the ICC recognized that, the complexity of buildings varies wildly. I mean, a simple detached two-story house presents a fundamentally different set of safety challenges than a 20-story office tower.
Or even just a mid-rise apartment complex.
Yep, exactly. So if you apply the same massive book of rules to every single structure, that small, straightforward home becomes prohibitively expensive. It becomes over-engineered.
Right. It would be total overkill.
Total overkill. So the ICC created a split to manage that complexity. They basically carved out the simplest, most common structures, your typical home, and gave them the IRC. It's a streamlined, much more accessible set of rules.
And then for everything else, they developed the IBC.
That's it. And this brings us to one of the most important concepts to grasp: the difference between a prescriptive code and a performance-based code.
And the IRC is what we call prescriptive. What does that actually mean?
The IRC is like the ultimate recipe book. It tells you exactly what to do. It says if you're building a wall, it must use 2x4 studs spaced 16 inches apart with this sheathing fastened with a specific nail. It gives you clear, direct instructions.
So if you follow the recipe to the letter, you're compliant.
You're compliant. It requires a lot less input from specialized engineers, which is why it's so popular for smaller builds.
Okay, I see. It offers certainty through really strict direction. So how did the IBC compare to that? Is it also a recipe book?
No, and this is where the really deep technical difference is. The IBC is fundamentally performance-based or objective-based.
What does that mean in practice?
It means the IBC doesn't usually tell you how to build the wall. It tells you what the wall must achieve. It has to have, say, a 2-hour fire rating, or it has to withstand specific shear forces from wind or earthquakes.
So the IBC gives you way more design flexibility. You could use concrete or steel or engineered lumber.
Or even new materials, exactly. As long as you can prove, usually through detailed engineering calculations, that your solution meets that performance standard, you're good.
That makes perfect sense. The IRC tells you what to do. The IBC tells you what result you have to deliver.
Precisely. And that's why the IBC is the code for complexity. It has to accommodate everything from a factory to a hospital.
So if the IBC governs everything that isn't an IRC structure, we absolutely need to nail down that definition. Where does the International Residential Code draw that line?
This is probably the most critical part for anyone listening who's planning a project. The IRC's scope it's surprisingly narrow. You have to satisfy 4 very strict criteria to qualify. If you fail even one, you're automatically in the IBC.
Okay, let's break down that 4-part test. What's the first one?
First, the building must be a detached 1 or 2 family dwelling.
Okay.
Or a townhouse. And a townhouse here has a specific definition. A single-family unit, no more than 3 stories, separated from the next one by a 2-hour firewall. So if your building has 3 or more dwelling units, you're out.
Wow, so that eliminates every triplex, every small apartment building right off the bat. It doesn't matter how small they look.
Doesn't matter, you're in the IBC. Second, the structure can't exceed 3 stories above grade plane.
And we should probably define grade plane because that trips people up. It's not just where the building hits the dirt, right?
Not at all. It's defined as the average of the finished ground level all the way around the building. So if you have a sloping lot, it's that average that sets your baseline. It stops designers from, trying to cheat the height limit by sinking the first floor.
That makes it much clearer.
Yeah.
So 3 stories max based on that average. What's number 3?
Each unit has to have its own independent means of egress. Basically, you have to be able to get out of your own unit without passing through someone else's.
Makes sense. And the last point.
The IRC also covers accessory structures, so garages, sheds, pole barns, but only when they're associated with an IRC-compliant home.
So if you meet all 4 criteria, 1 or 2 units, 3 stories max, independent exit, you get to use that streamlined recipe book.
You do. And that clarity is what makes it so appealing. You follow the instructions, you avoid a massive engineering headache.
But the second you cross any of those lines, the entire world changes. Let's shift over to the IBC.
It's a profound shift. When you jump to the International Building Code, you're in the Universal Code. And like we said, calling it the Commercial Code is just. It's dangerously wrong. It governs hospitals and schools, yes, but also all the residential buildings that fail that narrow IRC test.
This is where it gets really interesting. Let's talk about the triggers that are most likely to catch someone off guard and push them into the IBC.
The first one is height. It's the easiest one to visualize. That simple change from 3 stories to 4 stories is an automatic, undeniable switch to the IBC.
No wiggle room there.
None. The risk profile, especially for firefighting and getting people out, it just goes up exponentially at 4 stories.
I've heard of designers trying to get clever, claiming the top floor is just an attic or storage.
Yeah.
Does that loophole actually work?
It's an old trick, but building departments are wise to it. They shut that down immediately. I mean, if the space is habitable, if you can stand up in it, it's a story. Trying to play word games just gets you more scrutiny and more delays. 4 stories is a hard line in the sand.
Okay, so height is trigger 1. What's the second one?
Yeah.
Density.
Yes, density. Moving from a 2-unit dwelling to a 3-unit dwelling, a duplex, to a triplex, that instantly triggers the IBC.
Even if it's a small, suburban-looking building.
Even then, the code sees this as a shift from simple residential to a more complex multifamily occupancy. That requires more robust safety measures, like much better fire separation between the units.
And the third major trigger that I see a lot in urban projects is mixed use.
Absolutely. The second you have a cafe on the ground floor with 2 apartments above it, you're in the IBC, no question.
And why is that?
Because the code now has to manage the risk of different occupancies coexisting. You've got an assembly space, the cafe right below where people are sleeping. It vastly increases the complexity of everything. Fire ratings, ventilation, even the structural load calculations.
Okay, so we've crossed the line. Our project is now in the IBC.
Yeah.
How radically different does the engineering and construction get?
It changes everything. I mean, everything, down to the fasteners you use. Under the IRC, you're probably using simple, cost-effective platform wood framing.
Right.
Under the IBC, especially once you hit 4 stories or 3 units, you're moving into structures that require vastly improved fire safety.
What does that mean in, practical terms? What are you actually building differently?
It often means a complete switch in your structural system. You might move from that simple wood framing to required fire-rated construction. You might need to use non-combustible materials like concrete or steel for certain walls, or at the very least, much thicker, more complex gypsum wall assemblies. We're talking 2-hour fire ratings between floors or between units.
And what about safety systems? I imagine the IBC requires things the IRC just doesn't touch.
Oh, definitely. The IBC has these detailed occupancy classifications that affect every single part of the design. Once you hit that 4-story mark or that density trigger, you will almost certainly need an automatic fire suppression system.
So sprinklers.
Sprinklers, which are very rarely required under the basic IRC. You also have to design a much more rigorous means of egress system. So thinking about exit routes, signage, emergency lighting, fire ratings for stairways. It's a whole different level of detail.
So if a client comes to you assuming their little 3-unit building is an IRC project, and you have to tell them it's IBC, you're not just changing the paperwork. You're changing the entire DNA of the building.
That's the perfect way to put it. It requires the immediate involvement of structural engineers, fire protection engineers, It significantly increases your hard costs and the complexity of the whole project.
This really does sound like a trap. Let's run through a few quick real-world examples to make this stick.
Good idea. Let's take a classic suburban structure. A two-family detached home. A duplex, 2 stories high.
Okay, that's easy. It's 2 units, 2 stories, individual exits. That's IRC. It's the simple recipe.
Exactly.
Yeah.
Now let's take that same footprint, same look, but we make it a 3-family dwelling, a triplex.
That one extra unit pushes it over the density line. It's got to be IBC.
It is. So now you need more rigorous fire separation, maybe different stair designs, all of that.
Okay, what about townhouses? A whole row of them. Each one is 3 stories high with the proper firewalls between them.
That still fits the IRC definition of a townhouse. So that's IRC.
But the second you add a 4th floor to one of those townhouses,
It's immediately IBC. That 4th story requires engineered fire-rated floors, a more robust structural system, probably specialized fire safety systems. The whole game changes.
it's incredible how a building can look so similar on the outside, but underneath there's this massive regulatory and architectural hurdle.
And really, what this all comes down to is risk. The code is trying to manage risk proactively. The more people, the higher the building, the more mixed the uses, the greater the risk of something catastrophic happening in a fire or an emergency. The IBC is designed to address that complexity.
And these distinctions, they really do shape everything from the type of foundation you have to pour to your energy performance standards. So to connect this all back to you, the listener, getting this right from the very first sketch means you can budget accurately. It means your architect can set realistic expectations. You avoid that horrible shock of realizing your foundation needs to support a completely different, heavier fire-rated building than you planned for.
The smoothest projects I've ever seen are the ones where the team understood this distinction from day one. They knew if they were designing to the streamlined IRC recipe or the complex, performance-based IBC standards right from the start.
So to summarize the big takeaway here, the International Residential Code, the IRC, is that streamlined, prescriptive code. It's tailored to a very specific, limited type of building, 1 or 2 families, 3 stories max, and so on.
And the International Building Code, the IBC, is the Universal Comprehensive Code. It's performance-based, it's technically demanding, and it governs every other kind of structure: residential, mixed-use, commercial, industrial, you name it.
And while that distinction might seem simple on the surface, behind it is a whole world of architectural planning and regulatory nuance that directly hits your budget, your timeline, and ultimately the safety of your building.
Getting that clarity early really is the difference between a successful project and a complete disaster. It impacts the building for its entire life.
It really does. And as we close this deep dive, here's a final thought to consider. We focused on the current structure of the codes, but the source material we looked at mentioned how these codes are always evolving. It cited the 2021 IRC updates, which had critical changes to things like braced wall lines and deck design.
They're always changing.
So if your project is designed right on that edge, say a 2-family, 3-story home, and a new IRC update comes out that mandates significant, costly changes to wall bracing or energy rules, does that make the IBC, with its greater engineering flexibility and performance-based options, suddenly look like the more stable, more future-proof choice? Something to mull over as you plan your next move.